The final video in our differentiation series looks at using the chain rule with trigonometric functions. So if we have the function y equals sine of ax plus b, where ax plus b is our inside function, then we need to use our Leibniz notation. So dy by dx is going to equal the cosine of ax plus b, because sine goes to cos, and then multiply it by a, because that's the derivative of our inside function. So dy by dx equals a cos of ax plus b. If we look at y equals the cosine of ax plus b, we know that cos x goes to negative sine x, and our inside function is ax plus b. So dy by dx is going to equal negative sine of ax plus b, and that's going to be multiplied by a, which is a derivative of that inside function, and we rewrite that as dy by dx equals negative a sine of ax plus b. Now in trigonometry, if the power is after the trig function, then we're really writing this as y equals sine x all to the power of n. So this time the inside function is the sine x. So again, in Leibniz notation, dy by dx is going to equal n multiplied by sine x to the power of n minus 1. And then sine x differentiates to cos x. And then we can rewrite that as dy by dx equals n cos x and sine to the n minus 1 x, remembering that the power goes after the trig function. And if we do the same thing with y equals cos x all to the power of n, we need to rewrite the function so that we get the correct inside function. So dy by dx is going to be bringing the power down to a multiplier, n cos x to the n minus 1, and cos x goes to negative sine x. And then we're going to do some rearranging to bring the negative to the front. So dy by dx equals negative n sine x, and then it's cos to the power of n minus 1 of x. So in the first example, we want to differentiate using the chain rule, and we've got y equals sine of 7x plus 1, so our inside function is 7x plus 1. So dy by dx is going to be cos of 7x plus 1, and multiply that by 7, which is the derivative of that inside function. So dy by dx is going to equal 7 cos 7x plus 1. In the next example, f of x equals cos x all to the power of 4. So remember, when it's a power trig function, we need to rewrite it with the power outside of the bracket. So our inside function is cos x. So we're going to differentiate the outside function. So the derivative of our function of x with respect to x is 4 multiplied by cos x all to the power of 3, and then we're multiplying it by negative sine x, because that's the derivative of the inside function. So the derivative of our function of x is going to equal negative 4 sine x cos cubed x. So our final example, the depth d meters of water in a harbour t hours after midnight, is given by d equals 4 sine of pi over 6t minus pi over 3. A buoy floats on the water, rising and falling with the tide. And in part A, we want to find the depth of the water at 3 a.m. And in part B, we want to find the velocity and acceleration of the buoy at 3 a.m. So this is bringing together our rate of change, our composite functions, and evaluating a derivative. So we want to find the depth of the water at 3 a.m. and it's t hours after midnight. So that means that t equals 3. And we're going to substitute that into our expression for the depth. So d of 3 is going to equal 4 multiplied by sine of pi over 6 multiplied by 3, take away pi over 3. And if we simplify the inside of that bracket, we're going to get 4 sine 3 pi over 6 minus 2 pi over 6. So that we've got the common denominator, which gives us 4 sine of pi over 6. Now we're going to have to use our exact value triangle. So remember, if we start off with an equilateral triangle that's 2 by 2 by 2, each of the base angles is going to be pi over 3. If we then make it into two isosceles triangles, we have a triangle that has a base of 1, a height of root 3, and a hypotenuse of 2, and the upper angle is going to be pi over 6. So sine of pi over 6 is going to be opposite over hypotenuse, so it's a value of a half. So for d of 3, it's 4 times a half, and that gives us a value of 2, and our units are meters at 3 a.m. Now for part B, we want to use our rate of change to find the velocity and the acceleration of the boy at 3 a.m. So we know that the velocity is the derivative of d with respect to time. So v equals dd by dt. Our inside function is the pi over 6t minus pi over 3. So we need to differentiate the outside function. So it's going to be 4 cos pi over 6t minus pi over 3. And we're multiplying it by the derivative of the inside function, which is going to differentiate to pi over 6. And now we need to simplify the expression. Numerator and denominator have a common factor of 2. And so our velocity is going to end up being 2 pi over 3 multiplied by cos of pi over 6t take away pi over 3. Now we're still working out the velocity at 3 a.m, so we're working out v of 3, and that's going to equal 2 pi over 3 times the cos of pi over 6 times 3 take away pi over 3. And we know from evaluating the displacement that the bracket is going to equal pi over 6. So we've got 2 pi over 3 times cos of pi over 6. And that's going to equal 2 pi over 3. And this time it's cos of pi over 6, so that's going to be root 3 over 2. Now we need to do some simplifying, so we can simplify the 2 on the numerator and denominator. And so our final answer for the velocity at 3 a.m. is root 3 pi over 3, and it's meters per hour. Now we need to look at working out what the acceleration is at 3 a.m. Remembering that v equals 2 pi over 3 times the cos of pi over 6t minus pi over 3. And the acceleration is the rate of change of the velocity with respect to time. So a equals dv by dt. So it's going to be 2 pi over 3. Our inside function is that pi over 6t minus pi over 3. So we need to differentiate the outside function. So cos goes to negative sign. So it'll be negative sign of pi over 6t minus pi over 3. And we're multiplying that by the derivative of the inside function, and the inside function will differentiate to pi over 6. So now we need to do some simplifying again. So there's a common 2 in our numerator and denominator, so we can simplify that down. And then we need to multiply out in order to get our expression for our acceleration. So A is going to equal negative pi squared over 9 multiplied by the sine of pi over 6t minus pi over 3. And we want to work out a of 3 because we want to work out the acceleration at 3 a.m. So it'll be negative pi squared over 9 multiplied by the sine of pi over 6 times 3, take away pi over 3. And that's going to become negative pi squared over 9. And we know that the sine of pi over 6 times 3 minus pi over 3 is the sine of pi over 6. And going back to our exact values, that'll be negative pi squared over 9 multiplied by a half. So that means that the acceleration at 3 a.m. is going to be a value of negative pi squared over 18 meters per hour squared.